Good afternoon, open source community, and welcome back to beautiful Atlanta, Georgia. We're here on day one of 3 days of coverage at KubeCon, bringing you an exclusive and very special series celebrating 10 years of GKE. My name's Savannah Peterson with a absolutely brilliant panel to my left. Akshay, Kelsey, and Eddie, CUBE alum and VIP in Atlanta again.
Twice.
No less. This is becoming a thing for us.
I want you to come to Austin still, so I got to figure out how to do that.
I'm all about that. We'll talk about that.
Right,
We'll stick Bobby on it. We'll find out what to do next. But we had a lot of fun last time. I'm really excited to dig even deeper talking about inference today. Sure. I'm going to open it up with you because this has been a big year of GKE inference-focused announcements, development, and collaboration. Can you give us a little recap?
Yeah, sure. So if you think about from us next, when we started kind of talking about all this, right? So inference gateway starting at the top of the stack. And I think we looked at the customer journey. What is that customer journey for this new kind of serving workload, right? So we talked a little bit about that inference gateway. And then even going further, like how do I then, okay, great, I've got a gateway that lets me get to what I need to, a more performant, better performance, but where do I even start? How do I know what accelerator to use, what model to use? So then working with our team on making sure that we have good referenceable benchmarks that a customer can use and then compare that to what they're doing with our GKE inference Quickstart. And then going through all the announcements that we did with our partnership with Ray and working in the open source with vLLM. So I think if you look at the whole stack, it's us looking at what is that customer's journey to learn what it means to inference a workload in this new world of serving and then figure out what does that pathway look like, and then what do we bring as Kubernetes and as contributor to Kubernetes and as GKE to bring to the fold to make it the best solution for the customer, right?
Go for it. I can see you're chomping.
Yeah, no, I just wanted to drive off what Eddie is saying is actually in KubeCon EU we launched inference API primitives in Kubernetes in the open source, and the working backwards from that is we spoke to customers and they're like, traditionally in web services, like which Kubernetes is really built for, the request response pattern is quite predictable. Like you hit a request endpoint, it's a web service, it reads from a database and you respond, and then you get predictable request response patterns. But then with LLMs, you can have a request saying, just like a FAQ, like how's the weather kind of request, which is like pretty predictable. Or you can say, summarize this document with a ginormous document. So the load on the back end varies a lot. So we heard from customers and they're like, hey, there's a lot of variance here.
I was just going to say, there's a lot of different form factors of what these workloads and use cases look like. For you building it, that's a lot of complexity as the creators of this foundation as well.
Exactly, so then we went to first principles 101, we're like, hey, load balancing does round robin, which expects predictability. Let's just have a custom metrics, read a custom metric from the model server, like something like KV cache, which is a good proxy, and then route. And then we're like, hey, there's benefit there. And that is effectively what Eddie was saying also is really important is what customers really care about from inference is performance. So if there's a performance benefit in terms of lower latency, higher throughput, sign me up for it. That's effectively what they would say.
It's what makes it real.
Exactly, what makes it real.
To the real world, it's inference that's making something instant or automatic or 10 times faster, 100 times faster than it used to be. And that increases the pressure and visibility of everything that you're working on.
100%. Yeah. And the one more fun fact is here customers...
We want all the fun facts. Bring it.
We're all about fun facts.
Yeah, customers, they don't... If you think about traditional Kubernetes, like a web service or a database, you get deployed and you take your time and then you optimize it. Here, it's redlining on day 0, because the whole point is to maximize the throughput on the accelerator, so there's no more optimizations on day 1 or day 2, it's day 0 performance maximization. Yeah. So from that perspective also, it was a big learning in that customers really want to get the most out of it. And then you got to assemble the Avengers, the best optimizations you got.
Love me a good Avengers.
I love the Avengers.
Yeah,
that's it.
The best optimizations you got to get the most performance of the hardware.
So in the Avengers, what role did Kelsey play?
He was the originator. He's Captain America.
Exactly.
Come on.
I was giving you a softball.
Cap. Come on. I started with Kubernetes up and running. That's how I learned it, right? So yeah, it's we kind of talk about how when we first started. Actually, we had a question yesterday at one of our events, right? And it was someone very new to Kubernetes, and they said, well, we thought Kubernetes was supposed to be only for stateless applications. I'm like, well, back then, right, when it first started, sure. But the world has changed, right? And stateful apps have been around now for quite some time, right after we changed the name and we finally found a name that stuck. But now it's like, this is now even more complex because we're going down to, the entire stack has to be completely integrated but composable, and that's the hardest thing. If I can be opinionated about a stack from my software and networking layer all the way down to the metal, I can build whatever anybody wants. But when I want it to be so composable, and which is Kubernetes is supposed to be, that's a lot of variability that has to happen at performance.
An incredible amount of variability.
Yep. So the amount of work that Akshay's team and our amazing engineering team and the stuff that we're doing is, it's literally building for something that is not just for today, but for tomorrow, and potentially all these new workloads that are coming in that don't meet the pattern today, but we want to make sure that there's something there for that next pattern, right? And then what Kelsey built and the team built back in the day was, this is something that can orchestrate all that with these principles.
Yep.
And look, now we're at this new level and it's still working. Yes, we still have to do work. We have to carry, we have to chop wood and carry water to get there. But it works, right? Yeah. And we're getting there, so yeah.
Yeah. It really does. It really does work there. Kelsey, did you anticipate the robustness of GKE? I know you had predicted that we would be sort of to this stage, but to your point, we're anticipating, and I almost think of it as like melting wax or like clay. You've sort of got to get into these crevices before they're even fully defined yet. How do you build for a future like that?
Most platforms are a snapshot on the 10 years previous. OpenStack is a snapshot on how people thought about infrastructure 10 years previous. And we think about all the platforms that have come in between, they're always snapshots on how one company or one community has been practicing things. When Kubernetes comes out, there was a critical decision. Brendan Burns, one of the pioneers of Kubernetes, I remember sitting next to him in the Seattle office, and we doubled down on this concept called custom resource definition. Kubernetes is a workload API platform, and we knew we were never going to figure out every type of workload, so we started with the simple web apps. Yep. There was no volumes, no configurations, no secrets, and those things got added over time for the workloads that we understood. But we always knew that there's going to be workloads that we wouldn't be able to define because we don't know about them yet. Right. So we put a first-class extension point. And what that meant was that Kubernetes always gives a type system to a practice. So the community practices things. Inference is still something people are trying to perfect. We've seen people try to do it the old way and then better ways. But what Kubernetes allows you to do is take the practice and turn it into an API. And so I think a lot of the things you've seen Google kind of release over the years have been saying, what are people actually doing in production? And can we codify it so the next generation of people that are trying to do it for the first time, they're not starting over from scratch. Yeah. So that's what Kubernetes is, and I think that decision to make sure that was going to be extensible was one of the things that allows us to do this without starting over from scratch.
100%. Inference gateway is a Kubernetes CRD, which effectively allows us to extend, and now we're in the world of inference.
That's right.
Yeah. I think that's a really good point, and I love that you just brought up you're never going to know everything you don't know yet about how something's going to be used. I think a lot of people like to pretend like they're going to know, and it just doesn't work like that. No. You never know what's going to happen until something's out in the wild. You said something that was really interesting when we were getting warmed up about being hardware agnostic. That is a challenge. How are you doing that internally?
So we're actually working with
I say that with love.
It is hard. It is hard.
I think we're working a lot with the open source model server communities. This is where, this has been an extension point to Kubernetes, because before, again, in the web service world or in the stateful world, applications were quite decoupled from the hardware, but we said, everything is
almost
coupled.
Entirely in a lot of cases. Yeah.
So now we had to extend where who the communities we work with, and some of the communities that are really important now is, for example, the vLLM community. They're an open source model server which works across both GPUs and TPUs. So we're working with a lot of communities to really think about inference in a way which is reasonably hardware agnostic. It takes some work, but it's getting there. And what is also the fun fact is a lot of these optimizations, the inference optimizations, they're also written by university researchers. And they are if you can, they're effectively get access to a hardware that they'll actually think about how to write the optimizations. vLLM was born out of the UC Berkeley lab. So there are a lot of nuances of working with the researchers, research communities, the open source communities in some of these frameworks to really make it work well across hardware.
I think they're the most optimal because like they can be scrappy.
Yeah.
Because they're researching. Like enterprises can't be scrappy as much because like we have stockholders we have to take care of.
We have to pretend there isn't this big mess in innovation,
exactly.
even though there always is a bunch of stuff on the floor as we're doing this.
So loving the fact that we can get like that bleeding edge thought process, but then really quickly the channel and then the community that was built by Brendan and Kelsey and the whole team and Tim and everybody, and building that community come together saying like, now there's a fast path from this researcher at a university thinking this is cool and this is how we're doing it to production at a hyperscaler.
Yeah.
Right.
And then have a
which is wild.
Yeah,
like just to double down on that, the thing that's inspired me personally the most over the last few years is the true collaboration between enterprise, a startup, research, government.
Yep.
We can't build the future unless everyone's at least communicating.
That's right.
100%.
And it's quite a moment for all of the nerds in the world. Like,
yeah.
It also helps that the workload is so expensive to run.
Oh yeah.
That there's
Important
incentive
yeah.
to try new things that can reduce the cost.
Yeah.
Absolutely
Because
right.
when you talk about a 5% difference in cost, most people will say, we'll just keep it as it is.
Yeah.
When you talk about huge contributions that reduce the bottom line greatly, sure, I will try that experimental thing if it's the best solution for me to even attempt to run this workload.
Yeah.
100%. It's like an open marketplace and anybody can come and contribute and the best optimization wins. To your point, even if it's experimental, it can drive a lot of optimization, so I'm going to use it.
That's right.
That's 100% the way.
And it continues the flywheel of creativity,
Yeah.
It does.
I think, within this community, which is a really unique piece of this. You touched on a conversation you were having, Eddie, with someone who was just getting started with Kubernetes, and I actually want to bring us up just for a second because it can feel potentially overwhelming hearing some of the conversation here, seeing us celebrate 10 years of GKE. The reality is there's still a lot of people just getting started, especially as with the AI workload catalyst that's been happening. So I would love to hear your three very inspiring people. What would be your advice, Eddie, I'm going to you first.
Okay.
What would be your advice for someone getting started or trying to figure out how to navigate this right now?
Yeah, I'd say one is just, I think we had a question just like that, and we said, look, understanding those base principles about these are resources that you can use and there's an API to go to it and it's an orchestration engine. Understanding at least those kind of base principles, I think is almost like a critical step in realizing this is a lot more than just like a web server that's running on a server, right? It's something that does a lot of things, has a lot of moving parts. And everything else is just an upscale from there, right? Everything else is just a deeper dive from there. But I would say understanding in depth, like what does it mean to say, when Kelsey says, we have a resource and that has a type, and that type has a certain contract, and this is what that contract should look like. And then and then the next layer right below that would then be saying, how does Kubernetes handle that type when certain things happen, so that you understand what's happening behind the scenes, right? I mean, to me, like coming from learning from Kelsey, and like I got to work with also Brendan and understand the distributed computing concept and say, well, how is it all this being reconciled and going through the controller? Like, that goes deep, but at the same time, it was almost like a light bulb went off. And it's like, this is more than just, I'm running a container somewhere. There's something that's making intelligent decisions about where things need to be, and it has to follow a pattern. And then once you get that, you start to then, all the pieces start to fall into place. And I mentioned this on our last podcast, inference is just another workload. Highly specialized serving workload, for sure. But it's just another workload. So if I can get those principles of what does it mean to scale a web service to millions of pods and containers and so on and so forth, the next step is like, okay, now I just need to know like where those other things run from, but it's the same kind of concept, right? Different scale, different economics, but it's the same.
Well, it's another thing that's got to get done if we're going to make all this real. So it makes perfect sense. Kelsey, what about you? What's your advice? You've probably given more advice about this than anyone, perhaps. So yeah, how has it changed today?
I remind people that they're getting started, but they're not starting over. And I think a lot of times when companies approach these problems, they're thinking they're the first people in the world to solve these problems. Just like when you write code, we don't write libraries from scratch. You go find one that works.
Right.
We find frameworks that are tried and true, and we bring those in. Kubernetes is an infrastructure framework. And a lot of work that we're doing, we're making new infrastructure libraries. And whenever a new database shows up, new drivers and frameworks show up. And there's nothing different about this example. So even if you think you're a unique snowflake, you're probably not.
Real talk, you're not.
Yeah, and it just makes a lot of sense to say, what is the industry doing? And Kubernetes is one of those rare instances where the community has found Switzerland in Kubernetes, and we try to make these ideas work there because the value is around Kubernetes. And we found comfort in making Kubernetes the operating system, and we contribute our drivers, we contribute our abstractions, so you can get on with the rest of it. So that's the way I would encourage people to look at it. If you're getting in here late, you have the late mover advantage. People have been doing this for a decade. You just get to inherit the maturity.
I love that. That's a great way to look at it, and thinking of Kubernetes as the comfort food on what is a bit of a roller coaster ride for all of us right now, to tie together our food analogies. All right, what's your advice?
I think my advice is similar to what Eddie and Kelsey said, but in a little bit of a spin, in that we're in a moment where it's in the early days of Kubernetes, where so much is in open source. To your point, the communities are all working together. So everyone's actually learning on the fly.
It feels good. It feels safer to learn on the fly.
It feels safer to learn on the fly, so you can absolutely ask the dumb question. There's no stupid question. So then you can actually ask the one-on-one question, and I feel like in general the vibe is more around curiosity, exploration, and really optimization of a specific hardware. So I think it is actually far more approachable than it seems to be. We on GKE have released like a bunch of quick starts. We're constantly doing benchmarks. We're trying to make sure, as Eddie said, don't focus on the differences, focus on the similarities, because there's so much which is similar. And the difference is only the small point. And even the differences, there's a community of people who are there to help out. There's so many Slacks which are so active. Like if you look at the vLLM Slack, there are questions on Kubernetes, there's questions on a new model, there's questions on all sorts of stuff. So there's a lot of community, so you can jump on board if you're ready.
Yeah, I love that as a note. That I couldn't agree with that more. And there's plenty of people who want to help. We all had to have help when we got started too. Nobody's above, reaching out or saying, hey, this is actually how I do it. Come over, look over my shoulder, or whatever that might be, or come play in my sandbox. I think that's really important. Okay, I've got one final question for you, gentlemen. Last segment I asked Kelsey where this was going to be in 10 years. But I'm going to bring it tighter because we're moving fast and we're talking about inference, which is obviously fast and it matters. When we're hanging out at KubeCon in Salt Lake City in 2026, or Amsterdam if you're feeling ambitious, totally up to you. What do you hope to be able to say then that you can't yet say today? Actually, I'm going to start with you.
That's a tough one.
Look, some of the best platforms in the ecosystem right now actually come from the non-vendors. So the thing Google done really well is we married Kubernetes to the cloud. We abstracted away the pain points that it takes to run it. But some of the best deployment software comes from a tax company. Some of the observability comes from...
Which is wild to think about, straight up, Kelsey. We don't think of the tax companies as the number one on the innovation.
I think Google's always done a good job of making sure that we build solutions that are componentized. So what I think is going to happen next year is when customers that are using this in production get their hands on it, they're going to customize it to that final step. It's like going to the grocery store, buying your own ingredients, but when you get home, you decide if you want to modify the recipe a little bit to your own taste. So once these things get released, the announcements went out, when customers get their hands on it, someone's also worked in the cloud for a number of years, we step back and observe like, wow, we never imagined people will take these components and do that.
It's so cool, right? That's got to be one of the most fun
parts. I think in 2026, we'll see someone on that stage talking about that thing we never thought that they were going to do.
And I would even double down and say, I'm hoping aspirationally, what we see is those very big, the foundational model builders, the Google DeepMinds, the Anthropics, all of the ones that are at the edge of it, they're going to say, we always have to have our competitive piece, but we're going to be able to trickle those down to the startup, to the smaller company. We're still kind of all in the same boat right now. But once these larger organizations start doing these at scale, at high performance, at a low cost. And then I'm hoping that aspirationally Google Cloud specifically, when having relations with these customers, can bring that information down in a more consumable way for the every customer. The federal government, the bank, the healthcare provider, the startup that's just starting up a little app tomorrow, they should all be able to say, I can play the same way that these big guys are doing it, but at my scale. And I think that's what we can do.
My car can look different, but the engine's the same.
Yeah.
Yep.
Yeah, no, I love that. All right, now we're coming back to you. You got an extra bonus minute there to think of your...
No worries, yeah. I just want to summarize what Eddie says, because I feel the same way. Probably inference should just be the new microservice. It's just another workload. And people should really be talking about the value they get out of it in terms of the productivity gains, in terms of how it's transforming the organization, and how they're doing it at low cost and low scale.
Awesome.
High scale, yeah.
Well, I can't wait to see the thing we never thought of, and all of that being done at scale, at low cost, and perhaps efficient for our wonderful planet. Gentlemen, thank you.
Yeah.
This has been really delightful. And thank all of you for tuning in to our fabulous VIP special series with Google Cloud here at KubeCon in Atlanta, Georgia. My name's Savannah Peterson. You're watching theCUBE, the leading source for enterprise tech news.